Hey class, we're continuing with our geometry section area now. We are getting into parallelograms, triangles, and trapezoids. So we're trying to find how many unit squares can fit inside our given figures. So let's take a look. First of all, we're going to talk about parallelograms, area of a parallelogram, but before that, let's talk about some terms. The base and the height. This is very important to identify the base and the height correctly in these figures. The base and the height must be perpendicular to each other. Okay? So the height is the altitude, which by definition is a line segment perpendicular to the base. So the base is just one of the sides of the figure, or in this case the parallelogram. The altitude must be perpendicular to that, and it must go touch the other side. So look inside the box here. Most of you know this, but the area of a parallelogram is base times height. If we remember our chart from yesterday, what other figures are parallelograms? Well, this also refers to rectangles. Rectangles, the area of a rectangle is also base times height. Other parallelograms are rhombus and square. Now, a rectangle, the sides are perpendicular, so that's nice being able to find the base and the height because those are just your two side lengths that are next to each other. A square is also nice because it is perpendicular, but we also know that the sides are the same, so it's just side times side for a square. But in the most general sense, it's just base times height. So let's look at some examples here. What's my base and what's my height? Well, to me, my base looks like it's 16. It doesn't always have to be the bottom. A lot of people get stuck on that. The bottom number must be the base. That's not true. We're just looking for two numbers that are perpendicular. It's kind of the general sense. So 11 and 16 are perpendicular here, okay, from a right angle. So in order to find the area, I'm going to do 16 times 11. Okay, and after I do 16 times 11, that just gives me my area right there, 176. And our label is square inches. So we're saying 176 1 inch by 1 inch squares can fit inside this parallelogram. Alright? So how we'd write that, if you didn't want to write it out the long way, but we'd write 176, and this represents square inches. Right there, little inches with a 2 above it. Exponent. Alright, so same thing over here. My base, I would consider it to be 6.2. The height, 7.5. So I just multiply those two numbers together. 7.5 times 6.2. And again, my label is going to be square centimeters. So I'm going to put square centimeters for my answer. Have to label all your answers. You will lose points on every assignment if you do not correctly label your answers. And so this one's 7.5 times 6.2 gives me 46.5 square centimeters, aka 46 and a half. So 46.5 square centimeters. A couple of guided practice if you want to try it down there. Moving on to triangles now. Triangles go based off of parallelograms. In fact, we found parallelograms based on triangles, but here's the area of a triangle. It is half base times height. Well, base times height was a parallelogram, and I'm telling you that a triangle is half of that. Well, look right here. I have a parallelogram made up by two triangles. They both have a base of 4. This one's 4, this one's 4. Both of them have a height of 2 straight up and down. 2, 2. So it takes two triangles to make a parallelogram. So it must be one triangle is half of a parallelogram. So it's half base times height. Alright? So we're going to use this formula for all of them. Now, the key thing here is when we do the half multiplication, we can mix around. We can do, we can do base times height first and then take it times half. Or we can take half times height, then times base. The order doesn't matter because it's all multiplication. So we're going to talk about making smart decisions of what we're going to take half of. Okay? So let's look at some examples. Here, example 2, part A. Here's a good example to write down. Base is 8, I would say, and the height is 5.2. Okay, so what I'm going to do is write down the problem first. Alright, that's a good start. Okay, now to me it would be smart to take half of 8, because most of us know what half of 8 is. It is 4. And then do 4 times 5.2. 5.2. And so I'm going to get 20.8. And what's my label going to be? Square meters. 20.8 square meters. Okay, and now what they did up here, they estimated. Okay, so they said the answer should be around 20, which tells us it makes sense. So let's look at this example. What number between 4.5 or 6 do you think it makes more sense to take half of? I would say 6. What's half of 6? Well, half of 6 is 3. So I'm going to do 3 times 4.5. Now, if you took half of 4.5, it would still work out, but half of 4.5 is 2.25 or 2 1/4, which I think makes it even a little more difficult to multiply. This is not the easiest, but I think it's a little nicer. If I do 3 times 4.5, I should get, 13.5? 13.5, and my label is square inches, so I put it inches square. That's how many little 1 inch by 1 inch squares could fit inside this triangle perfectly. Alright, last example. Kind of save the hardest for last, but we're talking about trapezoids. A trapezoid is, again, made up of 2 triangles, but the triangles are kind of flipped. So let me highlight the 2 triangles. Here's one triangle, and here's another one up here. Let me do a different color. Do it in red. Okay, there's my 2 triangles. Now, this triangle has this bottom base as the base, and then the height. This red triangle has this top base as its base, and then there's also the same height. So what we do is we kind of average those 2 bases, where we kind of do both of them at the same time. So we're going to do half the height times our 2 bases added together. Alright? So again, we're just doing 2 triangles in one formula here. That's kind of what this is. Okay, we're doing the black triangle and the red triangle at the same time. So a trapezoid only has 1 pair of parallel sides. Those are always going to be your bases. The parallel sides will always be your base. So here's our last example, real world example. Anyone that's looked at the state of Nevada, it looks like a trapezoid. Okay, so what are my bases for Nevada? Well, my bases are always the 2 sides that are parallel. So it's going to be the 206 and the 478. Okay, so those will go inside my parentheses. So in parentheses, I'll put 206 and 478. And on the outside, my area is going to equal half times the height. What's my height of Nevada? Well, it doesn't have to go straight up and down to be the height. It just has to be connecting my 2 bases. So 318 is my height. So times 318. Okay. Doesn't necessarily matter at this point, but let's do this correctly. And order of operations, what do you think I would calculate first in this problem? Well, order of operations tells me parentheses first. So I do parentheses 206 plus 478, and that gives me 684. Okay, and I'm going to take that times 318, and also times half. Alright, so now, order of operations, they're all multiplications, so I just go left to right. Half of 318 is 159. 159 times 684 should give me how many square miles are inside of Nevada, and the answer is about 108,756 square miles. Okay? If you want one more practice of the trapezoid, there's a guided practice down here to try. Your height's 12.4. Here are your two bases. You'll plug them into the formula, and you should get an answer of 108.5 square centimeters. Go ahead and try that to make sure you know how to do trapezoids correctly. That concludes this lesson. Have a wonderful, wonderful day.